Hi everyone, I'm Vaishnavi Dasari and I'm an ML engineer.
Hello everyone, I'm Snehita Bodiga. I'm a full stack developer.
Hi guys, I'm Astrita Bean Setti. I'm front-end developer.
Hello everyone, I'm Abhisanath Reddy Aripalli. I'm a backend developer.
Hello everyone, myself Shoaib Khan Patan. I'm backend developer.
Hi guys, my name is Dhanush. I'm machine learning engineer.
Hello everyone, I'm Neil Kamal Rana and I am a full stack developer.
All right.
Okay, guys.
Nita, can you please start sharing your screen now?
Yeah, let's get started. Oh shit. One moment.
Right. So, our team is Cyber Sentinel. So, this is an AI powered personal cybersecurity assistant basically designed to proactively safeguard users against digital threats. Okay, by integrating what we did, advanced machine learning algorithms, we made sure that it gives a real time monitoring to threats detection as well as personalized security guidance to enhance users' online safety. Okay, can go to the next slide. Our agenda has been divided into six parts. That is, we divided it into team and planning, user and product definition, technology and implementation, project documentation and management, tracking and evaluation, demonstrations and resources. And there are subparts of it. Go to the next slide. So, like we all introduced, our team members are me, Vaishnavi Dasari. I'm a machine learning engineer. Then there is Snehita, who's a full stack developer, Ashrita, a front end developer, Abhi Sainath, a backend developer, Shoaib Khan Pathan, a backend developer, Dhanush is machine learning engineer, and Neil Kamal Rana, a full stack developer. So the improvements we have done from our previous sprint to this sprint are we improved our accuracy in AI models. We made sure that we have removed feature columns in this, and then we added API slides for sure. We made sure our test case ID has been added. We improved our team velocity. We made sure our key features have been delivered successfully and on time. Our backend integration was very smooth, and we have improved on our cross-functional collaboration. So coming to the project description, like our team is Cyber Sentinel and team is Tech Titans. And our project description basically it's like we are this team where we have individuals and enterprises who need protection against cyber threats. Everybody today needs it. So what we did was we made the Cyber Sentinel platform in a real-time AI-driven cybersecurity solutions that detects and prevents phishing attacks, fraudulent transactions, and identifies threat against advanced machine learning using advanced machine learning techniques, behavioral analytics, cloud-based threat intelligence. Okay, it's basically different and unlike any traditional security measure. We made sure that it struggles to detect sophisticated attacks. Okay, we have made our key features including user dashboard, recent alerts, system health check, and then we have done threat detection analysis using proactive monitoring, behavioral analysis, incident response, and used for personalized security guidance. We used even digital safety consultation, secure online practices, and vulnerability assistance. And then for automated security tasks, we used routine maintenance, threat intelligence integration, and for user settings and customizations, we gave them notification preference, account management, privacy controls. Okay, so this is completely about us. Benefit outcomes for our cyber sentinel would be real-time detection of and prevention of cyber threats, including phishing and fraudulent transactions, adaptive learning capabilities to encounter evolving attack techniques, seamless integration for automation and analysis for efficient, proactive cybersecurity. It's a very user friendly and intuitive design, making cybersecurity accessible to all individuals. So basically, what happens here is you will get an enhanced protection. It is time efficient and cost efficient. It will give you personalized support, and it is having a very user friendly interface. So that is our GitHub link. To summarize it, Cyber Sentinel serves as a comprehensive security companion combining advanced AI capabilities. Okay, go to the next slide. So our team agreement includes communication, professionalism, meeting cadence, and team members. Communication we have improved on WhatsApp as well as Zoom. We have made sure we have Google Docs to serve the platform for collaboration. We have weekly Zoom meetings and mid Zoom meetings too, midweek. Our team members have agreed on informing group in advance if they're unavailable, as well as discussion boards are focused, as well as all team is assigned work. Every team member has their own works, they're part of the codes, and finally everything is being collaborated by the end of the week. Professional includes mutual respect, being very transparent, being very respectful to each other, being supportive to each other, and being having a very constructive uh, words towards each other, and a constructive discussion. uh, we have meeting check primary meetings, we have check-ins and ad hoc meetings too, and final goes our team members. So I hand over further to my further teammate for personas.
So, hi guys, this is Dhanush, and here to discuss about some of the personas which we have taken for our project. So, first persona is Alex Johnson. His age is 32. His occupation is a software developer. So, simply, Alex works at a mid-sized tech company and is well versed in various technologies. So, he spends considerable time online, both professional and personally. So, aware of cybersecurity threats, but seeks advanced tools to enhance personal security in his company. So, his main goals are to protect personal and professional data from phishing and other cyber threats, and stay informed about at least cybersecurity practices, utilize AI-driven solutions for proactive threat detection. So, the challenges which he faced during this phase is balancing convenience without robust security measures, identifying trustworthy cybersecurity tools amidst numerous options. Those are the second persona which we are discussing is Maria Thompson, age 40, and occupation is project manager. So, manages a team remotely for a marketing firm, juggles professional responsibilities with parenting two teenagers, uses multiple devices for work and personal tasks too. So, her goals are to ensure the security of sensitive work related information, protect family members, especially children, from online threats, maintain a secure digital environment across all devices. And the challenges which she faced was limited time to manage and monitor cybersecurity measures and keeping up with evolving cyber threats and ensuring family compliance with best practices. So the third persona which we are discussing is David Kim, age 45, occupation owner of a local retail store. So basically, his profession was runs an online storefront in addition to the physical store, handles customer data, including payment information. So he has basic knowledge of cybersecurity but lacks specialized expertise. So the main goal which he wants to do is protect customer data to maintain trust and comply with regulations, prevent financial losses due to cyber attacks, and implement cost-effective security solutions without extensive technical knowledge. So the challenge which he faced was limited budget for cybersecurity investments and difficulty in accessing which security measures are necessary and effective. So the next thing which we are discussing is minimum viable product, which we call MVP. So the first MVP which we are discussing is phishing email detection, which uses NLP models trained on cybersecurity datasets to classify emails as safe or phishing, helps prevent social engineering attacks by identifying malicious content in real time. The, the second one is fraudulent transaction detection, applies anomaly detection techniques to flag suspicious financial transactions. This campaign supports real-time monitoring for enterprise level financial systems. So the third one is URL classification, analyzes lexical features of URLs to determine if a web link is malicious or safe. So this provides an added layer of protection against phishing websites and drive-by downloads. The, the fourth one which we are discussing is user dashboard, a centralized interface that displays alerts, threat levels, and risk analysis in real time. It allows user to monitor cyber threats and take quick prevention action. So this is our MVP. And the next which we are discussing is our technologies which we are using in this project. So for front end, we use React.js for simple and interactive user interface. For backend, we use Flasks, lightweight Python-based API, which is very useful. And database, PostgreSQL to store detected thread data. And hosting, we use AWS for cloud deployment and scalability. So the technologies which we're using here for AI and cybersecurity tools. First one is machine learning. In machine learning, we choose scikit-learn, PyTorch for phishing and fraud detection, and for security, OAuth 2.0 for authentication, OpenCV for URL analysis, and third one is threat detection models, which we use at NLP-based phishing email classification, anomaly detection for fraudulent transactions, and URL classification algorithms. So, algorithms, our friend will continue.
Thank you, Dhanush. And coming to the algorithms, we have vast number of algorithms, but for our project, we have chosen three types of algorithms which suits in our project. The main the main difficulty that we faced, or the main features that we chosen for our project is finding phishing email detection, fraudulent transaction detection, and URL classification. For these three features, we chosen burnt algorithm, bidirectional encoder representations from transformers, and autoencoder with isolation forest, and CNN plus LSTM algorithm. We have chosen BERT algorithm because it is a pre-trained deep learning model for text classification. As we want to classify the email as for to detect whether it is a phishing email or not, we need to classify it. So we have chosen the BERT algorithm, and it captures the contextual meaning of words, improving phishing email detection. And it is a fine-tuned on phishing email datasets for high accuracy. Coming to fraudulent transaction detection, we have chosen autoencoder with isolation forest. This this autoencoder reduces dimensionality and extracts essential transaction features. Isolation forest detects anomalies based on learned representations, and it is very effective for unsupervised learning, which is useful for detecting fraud without requiring labeled data, as we don't know whether the data is labeled or unlabeled. So we convert it to a labeled data, then we use autoencoder. And coming to URL classification, we have chosen CNN plus LSTM, that is convolutional neural network plus long short-term memory. This CNN extracts spatial features from URL structure, so which can be detected easily whether it is the URL is a fraudulent or not. And LSTM captures sequential patterns, improving detection of phishing URLs. And this is an hybrid deep learning model for better performance over traditional classifiers. This is for algorithms. Next slide, please. And coming to our architecture design diagram, for front end, we have chosen like React.js, which is very useful right now and very uh, like compatible to our system. And when the user interacts with the user interface, then the request is sent to the Flask API. If the request is accepted, then the Flask API reflects that request to the external security APIs, so which detects it is a threat email or not. If not, we use machine learning models like PyTorch based detection models to detect whether the email or the transactions are fraudulent or phishing emails. So this after that, whether we detect it is a fraudulent emails or transaction, then we uh, send that request to the PostgreSQL, which says it as a fraudulent or secured email. So this can be stored and reflect back to the user. This is our architecture diagram. Coming to the context diagram, as I already said, when user sends input like email, URL, or transaction, our system CyberSentinel will be like dividing it into a sum of the features like checking phishing and fraud, whether the email is fraud or not, and by using the AI detection models, and it reflects to the our system and notifies the user whether it is a phishing email or a fraudulent transaction. The the results can be stored in the PostgreSQL, and the data can be collected from that. And we are using external APIs for additional security information. That's it. Next slide, please. Coming to the ER diagram, the element that we have chosen for our user interface, like user, are user ID, name, email, password for the website. And for transaction that the customer user made, we have chosen transaction ID, user ID, account, timestamp, and status of the email or transaction. And as we are checking whether the email is a phishing email or not, so we need email ID, user ID, subject, sender, body, classification. And for the URL, we have chosen URL ID, user ID, URL, risk level. Okay. Next, Neeta will continue.
Hello everyone. And now coming to the sequence diagram drives through what happens when someone uses our system. So the user enters something like an email, a link, or a transaction, and the data goes from front end to back end. Our AI engine analyzes the data, figures out if there is a risk, and saves the result. Then the backend sends that analysis back to the user. It's a smooth back and forth that makes whole process fast and efficient. So now let's go to flow diagram. And here we are showing how the system reacts depending on what's happening. So it starts off idle, just waiting. Once someone submits something to check, the system springs into action, analyzing, scanning, and deciding how risky it is. So, based on that, it can classify the input as safe, suspicious, or dangerous. So, if it's a threat, the system alerts the user and logs the event so we can learn from it in the future. Coming to the class diagram, the class diagram breaks down how we have built the system using object oriented design, basically organizing it into reusable building blocks. So we have different classes for our users, emails, transactions, and URLs, each with their own roles and properties. So at the center, AI engine, which does the heavy lifting when it comes to the threat detection. This kind of structure makes our system more flexible, scalable, and easier to maintain as we grow. Now let's get started with product backlog user stories. Here we have the first part of our product backlog, focusing on the user stories. So these represent what the end user expect from the system. Each story is defined by a user goal, clear acceptance criteria, and is mapped to a sprint. Coming to the user story 1, a monitoring user wants to tag phishing history. This was completed in sprint 1 with 5 story points. And coming to the user 2, an email recipient wants to filter emails based on risk level. This is done in sprint 1 with 3 story points. Coming to the user story 3, a security admin needs to view threat statistics to evaluate performance, addressed in sprint 1 with 8 story points. Coming to the user story 4, admin wants to manage user roles and permissions and also handled in sprint 1, and this is rated as 8 story points. Coming to the user story 5, a reviewer wants to upload an email to detect phishing. This was planned for sprint 2 and scoped at 8 points. This slide continues the user story backlog, introducing advanced features expected in upcoming sprints. So, coming, sorry, coming to the user story 6, if finance manager wants to detect fraudulent transactions via uploaded data, this is part of sprint 2 and has a high complexity with 13 story points. And coming to the user story 7, a general user wants to check if a URL is safe. This is implemented in sprint 2 with 5 story points. Coming to the user story 8, a user wants to verify sender trustworthiness, also tackled in sprint 2 with 8 story points. Coming to the user story 9, a system user wants to get real time alerts, scheduled for sprint 3 with 8 story points. Coming to the user story 10, users can report false positives to improve model accuracy. And this is in sprint 3 with 3 story points. Now, my friend will continue from here.
Thank you, Snita. Hello, everyone. And probably I am here to discuss the technical stories. So I'll quickly go with the technical stories that we have covered in the sprint one. Like we have created the dashboard and probably we have assigned the users their roles, and obviously we have implemented the open authorization, which probably we are facing some problems and probably will be continuing that in the sprint 2 also. And we have also set up the AWS for the project. And yeah, so the coming to the sprint 2, the technical stories that we are covering in the sprint 2, the first one is we are integrating the bot model for phishing and email detection, so that probably we can detect the fraud emails. And probably this has a eight story points of 8, and this is the major thing that we started with the in the sprint 2. Can we have the next slide, please? Yeah. Coming to the other technical stories that we are covering in this sprint, the sprint 2 is we are implementing the autoencoder and probably the the isolation forest, which Asrita has explained us in the starting. And probably it was a very complicated thing, and we actually faced a lot of issues also into this. And I think we actually were actually able to implement that with some accuracy of around 92%, and it was a complex thing, and we are still looking to it because since we are running this model and we are still facing some issues because this model is directly accessing the user and we are still have facing some problems with the user. So we are actually using it in the test cases where we are not giving it the complete access to the users. And probably the other technical story that we are covering in this sprint is we are deploying the CNN and the LSTM model also. And probably this is the only thing that is working very good in this sprint and is less complicated to the other ones. And yeah, it's covering a story point of 8 points. The other things that we are covering, we are not covering in this, but yeah, still we have mentioned it here are in the sprint 3. And probably in the sprint 3 we have developed a notification system. We have still not started with our notification system. We are only running the things and can only see those things in our backend and not in the front end as a notification. So probably that is something we are looking forward to implement in the sprint 3. And the other thing that we can have is we are trying to develop, we'll also try to develop the mechanism where the user can give the feedback for the system so that it can help in detecting the fraud and the phishing emails. And that is also something that we are looking forward to implement in sprint 3. It's a small thing. We have given it 3 story points, and let's see in the next sprint what we can do with that. Can we have the next slide, please? Coming to the sprint 2 backlogs, we have many user stories and technical stories here that you can see, and most of the user stories and technical stories are the same that I and Snita have discussed before. It is just to make it a good presentation. We are writing it this way, and there is nothing new into it to explain. Can we have the next slide? Yeah, again, the same thing, the sprint 2 backlogs that I have discussed before, the user stories and the technical stories. Can we have the next slide? Yeah. important thing, the test cases that we have done in the sprint 2, as I mentioned earlier, that when we were connecting the when we were connecting the users and when we were running our machine learning model, and due to some authorization issue, when we are logged in as an admin or when we are logged in as a user, probably we are facing problem because the AI engines, they do not have complete access to everything, and probably we need to figure it out. And that is why you can see there are some failed test cases in the beginning, and most of them are related to the users where we need to give them access authorization, and we are still working on to it. We are still not able to figure it out. So now come to the good thing that we have implemented, and probably if we look onto the screen and the test case number 5, and it's mapped to the user story number 5, that is uploading a physical phishing email sample for detection. We were able to implement that, and probably the actual outcome and the expected outcome mentioned there was the same that we were wanting it. Can we have the next slide? And coming on to some more test cases, as you can see on the screen, in this screen we have all the past test cases, and probably the test cases were very simple in this manner, like upload a safe or simple sample, or evaluating the BERT model, which is most of the thing is like the model trained. Probably we have trained the model in the last sprint, and it has already gained some good accuracy, and probably that is how it was working in this sprint. And those machine learning things we were able to implement, and probably all the test cases regarding to that was passed. So uploading a transaction with known fraud pattern, obviously we created some fraud transaction pattern for the test cases, and probably the system was able to recognize those things, and the system was able to flag it, and at the same time the system was able to learn all those things with the machine learning algorithms that we have used. So probably we were got a very good success ratio of around 90% in all those things. So what I think is a very good success ratio compared to the machine learning model that we were expecting. We were expecting a near about 65 to 75% of accuracy, but we were able to get some better onto it. Can we have the next slide? Okay. Yeah, again, the same thing written in some other words. Next slide. Okay, so now I would like to hand over it to Mr. Shoaib
Mhm.
to explain you the more details of not so important, I'll say, but still important in
Yeah,
view of
that's okay.
project.
Thank,
Thank you.
thank, okay, thank you, Neil. So, hi everyone. So here is the sprint two stories which are completed in our project. So as you can see, the users like different users 5, 6, 7, 8. So as a user, so we completed this like 63 stories was completed in this project for in sprint two. And then the next slide was next slide, please. Yeah. Here is the slide which does the in the sprint to the which stories are not completed was like 13 user stories was not completed, as you can see here. And then coming to next slide, here is the team velocity. So team velocity, our team velocity for sprint 2 was 63 story points, and then up to 37 in sprint 1. And then next slide. So here is the team's historical velocity. Here in sprint 1 velocity, we got like 37 story points. In sprint 2 velocity, we got 63 story points. So this brings our average velocity to 50 story points across 2 points. So what, one second. So the graph here is shown like on the right shows, it shows like our trajectory, that the significant growth in the second sprint. Next slide. So here is the burn down chart. So here's our sprint to and then the here we have two things here. The orange line represents actual progress, while the yellow line is a planned pace. So we had a slight lag mid sprint due to failed test cases. So, but we caught up towards the end. Here, that's about the burn down chart. Next slide, please. here you can see the completion ratio. In the sprint one it's a 74%. In sprint two, like it's better than sprint one, so it's we are much better, so like it's 84.8%. So we, and then a solid trend has a, we have the right detection to through the sprint two. That's what we can see here. And then next slide please. So here's the retrospective. So we already done this though. Like here we have what went well, what can be improved, and then action items. In what went well, our teammates, some of like our teammates are like a model should be achieved with high accuracies, something like that. And then what can be improved, like we can improve some end spirit was rushed, UI violation log time, and then in action items, complete carried forward stories early, documentation, the machine learning integration was machine learning integration learnings, we need to improve on that. So that was a retrospective of this project, the sprint 2. And then here's the sprint 3 planning. Sprint 3 planning, like for sprint 3 planning, we plan to implement like real-time threat alerts and feedback mechanisms, continue the improving detection accuracy, and to carry forward the two uncompleted stories here. And then this will strengthen the system usability and the trust. So this was about sprint 3 planning for the next sprint. And then next slide. So here the application screenshot from this, like my friend will continue, Abhi.
Uh, Thank you, Shoaib. Hello, everyone. Like these are our application screenshots. Like this is our dashboard which we implemented. Like we showed it in the last sprint too. Like, can you go to the next slide, please? So you, as you can see, like we have added the risk levels, like where you can categorize and you can filter those the emails which are suspicious, which are safe, and like which have been flagged. You can we can know them. Yeah, can you go to the next slide, please? So we have added these new security tools in our dashboard, in which we have email analysis, transaction fraud, and URL checker. Like we added a CNN LSTM model for the URL checking, and autoencoder and isolation forest for transactions, like which is the most complex thing in this. And we added BERT for email validation. So this is a screenshot of that, like for our dashboard. And this is the screenshot of like for the URL which we tried, like as an example. And it's showing like it's warning potentially dangerous URL because that URL is not right. So this is our screenshot for that. Can you go to next screenshot? Like this is our code which we are going to push it tomorrow. Yeah. Can you go to the next slide? This is our GitHub link. Okay, and the application demo. Can I share the screen, please?
Yeah, sure. You can start sharing your screen,
Yeah,
Abhi.
just a second. Oh, okay. This is our dashboard. So, like as we discussed in the screenshots, like we have added these. These are the new ones from the last sprint. Like this is for email analysis. Like we can try to add email for analysis and those here. Yep. Just like we can add all these details. So we can just paste our email and it starts analyzing and it gives us a result like it's showing it's phishing email as we intended. Like so. So this is we can add it to the dashboard too if you want to. And okay, let's try a safe email now. Maybe might show. So this is a safe email. It should give us a good report. So this is also showing as phishing. Hmm, these two. Okay, and now we can try transaction fraud. Like we can we can upload a file like the CSV file, or we can just paste our transaction data over here. Analyzes for yeah. So like it analyzed all the data and it just showed the suspicious transactions. We can just analyze new data if you want to. This is for the transaction fraud and for the URL checker. You can just paste the URL, analyzes. So yeah, it's showing this is a potentially dangerous URL because it's going it's showing as intended. Let's try this one. Yeah. So this URL is good. Like it's showing as it should be it should show. So this is for these are the things which I added for this sprint and these security analysis tools. Yeah, that's it for the demo. Stop sharing. Okay.
Thank you all.
Okay.
Thank you
Thank
all.
Thank
you.
you, everyone.